Annie, the client has just requested a noise analysis. I know it's last minute, but you are on the plane, right? Plenty of time.
On the plane? How?
Cabin crew, prepare for takeoff.
You want noise? I give you noise.
You have one new message.
Hey Philip, Annie here. Sorry to bother you, but can you explain how I can create a noise analysis in Forma? I really have no plan. I'm also on the plane, and my laptop battery won't last forever.
Let's break down the noise, shall we? Noise analysis on a plane? Well, technically, with Forma you only need a laptop and a Wi-Fi connection. Because Forma lives in the cloud and many airplanes nowadays have Wi-Fi on board. If you don't have a laptop, it becomes a bit tricky, but even then you have options. Maybe on that on a later video. Now let's go back a bit. What is noise? Or let's say, what is sound? Sound is a rapid change of air pressure, which is picked up by our eardrums. You could call it wiggly air if you want. Imagine a three-dimensional wave of contracting and expanding air, and the frequency, the amount of waves within a certain period is measured in hertz. Many short waves
is high pitch.
A few long waves
is low pitch.
And noise is an overlay of many different frequencies, like in white noise, where frequencies are overlaid over the whole audible spectrum. It goes from roughly 20 Hertz to 20,000 Hertz. That is the audible spectrum we can hear. The amplitude of the wave is what we perceive as loudness, and that is measured in decibel. And how much it contracts and expands the air, that is what we perceive as loudness. And decibel is a logarithmic unit. That means a loudness changing from 50 to 60 Hertz is perceived as doubling in a loudness. Our ear is perceiving that as twice as loud. Now, what does Annie need for a noise analysis in Forma and how to set it up? Let's check it out. Head over to the Autodesk website, and there you log into your account, and from here you can access your Forma hub. If you haven't done this before, I would urge you to watch the first video in the series where I explain how to navigate the interface, how to look at the demo site, how to create a site, and how to import your model from Rhino. And we looked at this project here. This is one on the left. So underneath create new, we have two projects, and I want to use the same one I used last time in order to show you how to set up a noise analysis. Let's just open that one. All right, so you can see this is where we left it off last time. In order to run any analysis, we need a context and a location, a real location. So Forma knows what kind of data it needs to provide. What's great in Forma is that whatever you hover over is highlighted, but it's not just highlighted in the 3D model, but also in the layers here, and vice versa. So if you hover over these layers, you can see what is highlighted. And of course, you can turn off and on layers. The first layer is called site limits. If I click on this, it's highlighted. This is the actual site limit of my site. This is where the analysis focuses on. And within that, outside the context, are the buildings. The buildings I brought in from Rhino in the previous video. The buildings are not context. The buildings are the actual objects we want to test, or whatever is within the site limit. A few things have also changed here in Forma, for the good of course. So now we can much faster access any important tools to create volume, surfaces, roads, terrain, and so on. But even also to add extensions is here a bit more accessible. Now, I really love that Forma has implemented a noise analysis. It's something I really looked for in many other software packages, and it's pretty much just the first one I have encountered, and it's also super easy accessible. All analysis tools are just here on the top, and also the pictograms are just, they speak for themselves, and you can just pick out noise here very easily. Now, if I click on this, it just does a very rapid noise analysis. Nothing really happened here. Everywhere is 0 decibel. It's absolutely quiet. That would be quite eerie, I would say. What do we need to do in order to run this? So we have a warning sign here. It says here, missing traffic data. Add roads or rail tracks with traffic data in order to predict real-world noise. And then below, two things, a rapid noise analysis and a detailed one. One is a real-time prediction based on machine learning. So an AI model is trying to understand the noise based on the data it has learned. This is really useful during the design process. And then there's a detailed one. So when you are comfortable with your model, then you can jump into the detailed version. And below here, we have a decibel bar. That's also super useful to see which color is which amount of decibel. As we explained earlier, decibel is the loudness. The World Health Organization warns that a continuous exposure to decibel levels of above 60 to 65 are potentially harmful. That's why you can actually see here that 65 is the threshold here from orange, yellow-orange to red. As soon as it goes to the red, this is really not very healthy anymore.
Too much noise can cause permanent hearing deficiency, depression, mental health issues, and worse.
Wow. I never realized airplane cabins are this loud.
I want to stay within the analysis, but I don't want to see that green bar. There's another tool here on the bottom where you can adjust what you see. So I can, for example, here, change the transparency of your analysis. All right, how to add roads and how to add the data, the noise data to the roads. You can follow this guide. It's super easy. You don't need my tutorial. You can just use the guide here. There's these two ways. Add roads or end railroads. So you can build your road. You can also import your road from Rhino and then define it as a road. You can also look at if there's data available, then you can download the data. We have that in here. So that's what we already downloaded previously. If I click on this road, I have here grayed out with 6 meter traffic noise data, but it's grayed out. We cannot do anything. So that's why we have this edit base to make changes. If I click this here, I'm in the editing mode and now I can change that. Now let's go back here. I can select this, select here, I go a bit further, select everything, and then I can add my data. Now, in order to add the average daily traffic, we need to understand how many cars go here every day, roughly. Now, we could use the start guide here and follow the link to the government website. But I was thinking for this exercise, we just estimate. I asked ChatGPT for a logic answer. Now, it's not a major arterial, but because it's a business district, the amount of traffic changes drastically between weekdays and weekend. It's a fairly busy street and ChatGPT estimates an average daily traffic of around 5,000 to 8,000 cars. So I will add this here. And now the rapid prediction kicks in and we can see how much what we have now. I made a mistake. It suggests 5,000 to 10,000 cars. Let's say 8,000 cars. This is what ChatGPT estimates on the lower end of the range. If we crank up the saturation of that analysis, we can see, okay, this has changed drastically. I would say 8,000 cars sounds about right as an average. After recording the video, I thought I better double check what ChatGPT was estimating. And I headed over to the website Forma is suggesting and I looked up the site. This is the road next to the site. The site is here and there's a data point just right there. I click on it and click on this link, download traffic data, and here we are. It's all there, and I have to say ChatGPT was pretty spot on. So 6,731 cars, all in all 8,933. But even if we would go lower, let's say 2,000. You can see how that changes. Probably not much. You see, you still have quite a lot of noise within here, but it's great that we can see that so quickly. I go back to the 5,000, between the 5,000 cars and 8,000. It's quite similar. Now, we haven't added all the roads. So let's go back here. We can lower this and add these roads. 6 meter. There are maybe 500 cars. And the same here. Let's again look at our output. It gives us a bit more information. These are probably lower. I would say 20. That also has an influence on how fast the cars go. We can see how this is distributed. Now, if I think about my buildings, so imagine the lower portion is a shopping mall. And this building should be an office tower, and this should be a residential tower. I think now that if in the night there's much less traffic noise and during the day is a lot, should not the one in the back be an office tower and the one in the front a residential tower? Question. Nevertheless, whatever you decide, we can go in here. If we click on the building itself, it says here function unspecified. I can go here and say, okay, this is a residential tower and this is a commercial tower. And the one on the lower end is also commercial. Remember, we're still in our noise analysis. By the way, we can make this change visible. If you go here, we can select the function and we can see the function as a color. So based on that, we can very quickly decide, is our function at the right spot? I could imagine, and I'm not an expert on this, but I could imagine that the residential tower is better suited here, where during the day, people are in the office tower would benefit from less noise. And you can see that in the night it would drop to much less. So it's just my conclusion, really. And you can disagree, of course. This is not everything, because we also have a railway here. So let's add a railway. Railroad. Doesn't have to be perfect. Maybe I need to turn this off again. All inputs are required here. I also, again, don't know exactly what that could be. Let's ask AI again to get some starting number. ChatGPT suggests that there are roughly 500 trains every day and speed is around 60 km per hour. So now that probably has quite some influence. Let's see. I'll crank this up again. Question, has this changed a lot? I'm not sure. If we now go to rail only, that's really cool. We can look at rail only. It doesn't have too much bad influence here. If we just look at the road has much more influence. So guys, take the public transport, much better. So if we're happy now with this, we can run the detailed analysis. And let's maybe make this slightly bigger. I hope that actually changes that here. Let's see. Okay, let's run it.
I think I get it now. It's so much easier than I thought.
Okay, so this ran. It says here 2 to 10 minutes. It took me a bit longer, and I guess it depends on the complexity of the site, and maybe also because I increased the noise area radius. This is the blue circle, which then should include the neighboring buildings. Well, let's have a look how that looks like. Okay, that's quite interesting. So first of all, what I can see right away, it includes also the building facades. So that changes quite a lot again. Let's have a look. So on the bottom end, again, we have our decibel bar, where we could filter the areas which are in absolute red. These are the areas which will be not very healthy. So it gives us quite an interesting understanding of the site. We can also turn off and on the facades here. We can only look at the facades if we want and turn off the ground level. We can turn off the roofs. Actually, these places are perfect for roof gardens, seems like. We can also change here the daytime. Let's check in the night. Okay. That actually gives me some reassurance that the night is not too bad for residential building. In the evenings, there's quite a lot of noise hitting that building. It's very interesting. Although this is closer, in the night we don't have really a problem in any of these. With the slider, and how I understand this is you can swap between what we've previously seen on the ground plane versus what we see now when we turn on the three-dimensional space. It's pretty interesting. Now, you could run your different proposals and compare them. I showed that in the last video. I will not repeat it now. Please check that out. Now, I could go out here and rethink this again, but we will look at different scenarios, even automated scenarios, in one of the next videos. So that's how you set up a noise analysis in Forma.
You have one new message.
Hey, it's me again. Client now wants a wind study. We need to impress them, okay?
Oh God.
Ladies and gentlemen, we encounter some turbulence. Please return to your seats and fasten your seatbelts.